The vision of next-generation electric vehicle batteries is, well, really starting to look like it might become reality, thanks to a groundbreaking development coming out of China. Researchers there have managed to create a low-cost, solid-state lithium battery that not only matches the performance of today's top-tier batteries, but does so at an astonishing 90% cost reduction. This innovation could honestly catapult China to the forefront of the solid-state battery revolution, a technology that's been talked about for a long time but up until now has been pretty much out of reach. While electric vehicle batteries have definitely improved, they still face some pretty significant challenges. The current battery packs are bulky and heavy, which adds weight to the vehicle, and limits how far you can go on a single charge. There's also always a slight risk of fire, which is a real safety concern. In response, scientists have been working hard to enhance EV batteries. One exciting solution involves replacing the liquid electrolyte inside batteries with a solid material. This solid electrolyte could make batteries lighter, since solids generally weigh less than liquids. Plus, they could be safer, because solids are usually less flammable. And on top of that, solid electrolytes might enable faster charging, giving you more miles in less time. However, solid electrolytes have been, pretty expensive and tough to produce on a large scale. This difficulty has sparked a global race among scientists to develop practical solid electrolytes for everyday use. Recently, Chinese researchers announced a breakthrough. They've designed a new solid electrolyte that is both affordable and scalable. This development is a significant leap forward, as it suggests that these advanced batteries could soon become a reality. If successful, this innovation could lead to safer, lighter batteries, letting us travel longer distances without worrying about fire. This advancement moves us closer to the widespread use of these superior batteries. Major players in the industry, including Toyota and Samsung, have heavily invested in developing solid-state electrolytes, particularly focusing on oxide, sulfide, and chloride types. Among these, sulfides are favored for their superior performance. However, the cost remains a significant challenge. To make these new batteries accessible, the material cost per kilogram needs to be below $50, but traditional sulfide electrolytes often exceed $195 per kilogram. This high cost is a major obstacle to mass production, and researchers globally are working hard to find cost-effective solutions, though progress has been slow. That's where a recent breakthrough from a Chinese research team comes in. They decided to tackle the problem head-on by developing a completely new type of sulfide material called LPSO. The key difference: LPSO wouldn't require the most expensive ingredient used in traditional sulfides, lithium sulfide. This could be a significant cost-saving factor, potentially bringing the price per kilogram down to a more manageable level for mass production. The Chinese team's findings, published in a respected scientific journal, have sent ripples of excitement through the scientific community. If further testing proves LPSO performs well and can be manufactured efficiently, it could be the key that unlocks the widespread adoption of solid-state batteries and revolutionizes the EV industry. It's still early days, but this new development offers a promising glimpse into the future of electric vehicles. The secret behind LPSO lies in its design. Unlike traditional sulfide electrolytes, LPSO is built from just two readily available and inexpensive compounds. This translates to a dramatic reduction in material costs, a mere $14.42 per kilogram. That's a staggering 8 times cheaper than what it typically costs to produce other sulfide electrolytes. But there's even more good news. The Chinese researchers assure us that this lower price tag doesn't come at the expense of performance. In fact, LPSO retains all the benefits of the best current sulfides, including compatibility with certain types of anodes, which is crucial for battery stability. Speaking of anodes, LPSO seems to work particularly well with high-powered options like lithium metal and silicon. Tests even showed that a battery made with LPSO and lithium metal could operate for over 4,200 hours at room temperature without any major issues. Stability is crucial for any battery. Imagine charging your electric car and then having the battery fizzle out after just a few hours. Not ideal, right? Well, tests suggest that batteries made with LPSO offer, honestly, some pretty impressive stability. In scientific terms, they showed stable cycling for over 4,200 hours at room temperature. That translates to real-world performance. You could potentially use your EV for thousands of hours without worrying about the battery failing. This breakthrough by the Chinese research team puts them in a very strong position in the global race to develop the best EV batteries. While countries like Japan, South Korea, Europe, and the US have traditionally been the front-runners in battery technology, China's development of LPSO could give them a significant edge. Major car companies worldwide are scrambling to catch up, with some giants like Toyota and Samsung aiming for a 2027 release for their own all-solid-state batteries. However, with a potentially cheaper, more efficient and high-performing option in LPSO, China could be well-positioned to take the lead in this race. It's important to remember that LPSO is still under development, and the researchers are constantly working to improve its performance even further. However, the initial results are, honestly, incredibly promising. If LPSO lives up to its potential, it could revolutionize EV batteries. Imagine electric vehicles that are lighter, safer, faster charging, and ultimately more affordable for everyone. This could, significantly accelerate the adoption of electric vehicles worldwide, and really propel China to the forefront of this global clean energy revolution. The future of electric vehicles is looking brighter than ever, thanks in part to this exciting development from China. The potential global implications are honestly substantial. If China successfully establishes a dominant position in solid-state battery production, it could, reshape the entire automotive industry landscape. Other nations and companies may find themselves reliant on Chinese technology and supply chains, mirroring the current situation with conventional lithium-ion batteries. This prospect has actually intensified research and development efforts elsewhere, with governments and private enterprises in North America, Europe, and East Asia increasing investments to make sure they are not left behind. For consumers, the successful development of affordable solid-state technology really promises a whole new era for electric vehicles. The key advantages actually extend well beyond just lower costs. Vehicles could offer significantly longer ranges, maybe even exceeding 600 miles on a single charge, while drastically reducing charging times to just minutes instead of hours. The enhanced safety profile, by eliminating the risk of fiery electrolyte leaks, would address a major consumer concern. Plus, the reduced weight and size of battery packs would allow for more innovative vehicle designs and, increased interior space. However, the path from a promising laboratory discovery to a product on the showroom floor is, honestly, long and fraught with challenges. Scaling a material like LPSO from gram-level samples in a controlled lab environment to the ton-scale quantities needed for global auto production presents significant engineering hurdles. Consistency, quality control, and long-term durability over thousands of charge cycles all have to be proven under real-world conditions. While the initial results are promising, the true test will really be its performance in pilot production lines and, eventually, in vehicles driven by the public. The race is far from over, but China's recent breakthrough and its coordinated national strategy have without a doubt shifted the momentum. The development of LPSO is a clear demonstration that the barriers of cost and performance that have long hindered solid-state batteries are not insurmountable. It has injected a new sense of urgency and possibility into the global quest for the next generation of battery technology. And honestly, the coming years will be critical as the world watches to see if this scientific achievement can truly become the foundation of a cleaner, more efficient electric future. China knows that the competition is growing and isn't wasting any time to secure its lead in the EV race. The country is taking a big strategic step. China's battery makers and car companies are joining forces in a government-backed initiative to build a complete supply chain for solid-state batteries by the year 2030. So this ambitious plan, which was launched back in January, goes by the name of China All-Solid-State Battery Collaborative Innovation Platform. It's a team bringing together government support, leading academics and industry giants like CATL and BYD, all working toward the same goal. This move shows China's determination to stay ahead of the curve. As Chen Liquan, a leading expert often referred to as the father of the Chinese lithium battery, puts it, solid-state batteries are the future of rechargeable battery technology. In an interview, the researcher stressed the importance of being first. Only by seizing the first opportunity can China remain in a proactive position in this race, he declared. China's all-out approach with this consortium shows they are serious about grabbing that opportunity and solidifying their dominance in the electric vehicle market.